This is section 3.7, rational functions. So we've been talking about different polynomial functions. Now what we're going to look at is look at the rational functions. So I'm just going to call rational function r of x to be rational, r for rational. And basically what a rational function is, just a polynomial function divided by another polynomial function. Okay, so here p of x and q of x are polynomials. So you basically are just dividing these two polynomials together. Now, one of the things that we know about rational functions already is that the domain of rationals is all real x values except where the denominator is 0. So that's something that we've learned in the previous chapter. So so that's kind of what we know about the rationals. Now there's a couple of features that the rationals have, and I'm going to explain them here. So this is kind of how we're going to be talking about these rationals, because the whole point of this is that we want to be able to graph them. So the first thing to know about rationals is that some rationals have vertical asymptotes. Some of them are going to have horizontal asymptotes. Some of them are going to have something called holes. And then something else that they're going to have is a slant asymptote. Okay, so these are 4 different features that these rationals can have. And just to give you a little reminder, because you should kind of know what an asymptote is from trigonometry. But an asymptote is basically a line that the graph approaches but never crosses it. Okay, so there's a line that the graph kind of approaches. I misspelled approaches. But it just never crosses it. I'm going to give you a little warning sign here. And I will say right now that horizontal asymptotes can be crossed. The only one that cannot be crossed is the vertical asymptote. Okay, so horizontal asymptotes cannot be crossed. Okay, so now let's start off with what basically a vertical asymptote is. So, and I'm gonna call vertical asymptotes VA. Okay, so when do you have a vertical asymptote? Well, if you remember about the tangent and the cotangent curves, and also the cosecant and secant curves, those have vertical asymptotes wherever the denominator was undefined. Okay, so here the vertical asymptote will occur when the denominator is equal to 0. Okay, so this one can never be crossed. So you cannot cross a vertical asymptote. So the way that you really find it is basically set the denominator equal to 0 and you'll have your vertical asymptotes. Okay, what about horizontal asymptotes? I'm going to write those as HAs. So these guys, you basically have 3 scenarios. So a horizontal, if you think of a vertical asymptote will have kind of like a, oops, that's wrong. That's horizontal. A vertical asymptote will have just a vertical line like this. And sometimes the graph may look like this. Oops, or something like that. I don't know. Let's just say it looks like that. Horizontal asymptote kind of looks like this. It's a horizontal line. And then maybe you might have a vertical line here too. And it's getting close to these graphs, but it's not touching them. Okay, so that's an example of a vertical and a horizontal. Now, with the horizontals, there's three scenarios. And I'm going to say here that these can be crossed. There are situations where they can actually be crossed. So the first scenario, I'm going to call it A, is going to be when the degree of the numerator is greater than the degree of the denominator. Okay? If this happens, if the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. Okay? Later on, when we talk about slant asymptotes, you might have a slant asymptote, but we won't talk about them right now. The second scenario would be when the degree of the numerator is less than the degree of the denominator. In this case, the horizontal asymptote is at y equals 0, always. Okay? And then finally, part C, the third scenario, is when the degree of the numerator is equal to the degree of the denominator. Okay? And if this occurs, that means horizontal asymptote is at y equals the leading coefficient of numerator divided by the leading coefficient of the denominator. Okay? So these guys, the vertical asymptotes and the horizontal asymptotes, horizontal asymptotes is a little harder to find, or they're not that hard. Just three different cases that you got to think about. Now, the vertical asymptotes, it makes sense why the denominator has to be equal to 0. Why do we have three different scenarios? Well, when you talk about limits in calculus, you'll kind of understand these. But the whole point of this is that you kind of want to think about the end behavior, what's happening to the horizontal asymptotes as x gets really, really large. So if the degree of the, let me just give you a really quick example. So you can see that if I had x squared minus 2x divided by x minus 3, okay? You can see that as x gets very, very large, the degree of the numerator, this guy is going to get very much larger. Okay, so this guy gets really, really humongous, faster than this bottom part. So basically, this guy is going to go to infinity. So it's not going to approach anything. So when the degree of the numerator is greater than the degree of the denominator, you're going to have no horizontal asymptote. Okay, if you have the degree of the numerator being less than the degree of the denominator, which basically means that you kind of have the opposite now. This means that this guy is going to go to infinity much faster than this guy. So the bottom part is getting really, really big. So when the bottom part gets really, really big, if I have like 1 over infinity, this whole bottom, the whole fraction is going to go to 0. Okay? If you have the same exact, if the degrees are the same, well, let me choose a different color. So let's say you have 3x squared minus 4, and then 4x squared plus 7. When you have these guys, both of them are going to get really, really large. However, you will see that they're going to kind of level off at this particular ratio. Okay, a really quick way to do it is kind of to divide everything by the highest power, kind of like this. Notice that the highest power in this case is x squared, or x squared over x squared plus 7 over x squared. You can kind of see that these guys are going to kind of cancel out and level off. Here, the denominator, as x gets really, really large, this thing is going to go to 0. And so is this guy. This guy's also going to go to 0. So all you're left with is this 3/4. Okay, so you just have the leading terms are basically going to dominate everything else. Okay, so that's kind of a little bit of the intuition of where these things come from. I'm happy to explain it to you. offline if you want to, but that's I kind of want to give you guys a little glimpse of where these horizontal asymptotes come from. Now, when we talk about holes, and I'll briefly talk about them here. When we talk about holes, one of the most important thing to do when you have a hole is they kind of act like the vertical asymptotes. Okay, so basically the way that you know if you have a hole is if two factors cancel out in the denominator and numerator, you have a hole at that factor. Okay, so the hole will be whatever you cancel out. So for example, let's say I factored something. Then what's going to happen is that notice that the x minus 3's cancel out, and you're left with x plus 4. And what it says is that at x minus 3 equals 0, you will have a hole. Okay, that's basically what it is. So that's how you know holes exist. The last one is a slant asymptote. And I'm just going to write SAs for these slant asymptotes. So a slant asymptote is, or you know that something has a slant asymptote if the degree of the numerator is the degree of the denominator minus 1, okay? Or you can say, or the degree of the numerator plus 1 is equal to the degree of the denominator. So all that this is saying is that the top part, x squared minus 3x, is always 1 degree more than the denominator. Okay, that's basically what it's saying. And the way that you know how to find the slant asymptote is use long division. Okay, so use long division to solve for the slant asymptote. And we'll do a problem for all of these, okay? So right before we jump into the problems, I do kind of want to give you a little glimpse of how to graph these. So how do you graph? So the way that you graph them are the following ways. So the first step is you want to factor everything as much as you can. The second thing is find x and y intercepts, okay, if they exist. Then find the vertical asymptotes, okay, or holes. This is if things cancel out. Find horizontal asymptotes. And then finally, sketch the graph. And use any additional points. If necessary. So if necessary, you want to be able to use any additional points that you want. Okay? Alrighty, so one of the things that we're going to try to do in the next video is we're going to just jump right in and do a lot of the graphing ones. They can be really tedious in the beginning, but as long as you practice, you should be able to get them really nicely. So we'll do a couple of the graphs in the next video.